low pass filter experiment, we'll be using an op amp. Why? Because in an ordinary low pass filter, if you just give an input, the output will be lower than the input. In other words, the signal will be attenuated. By using an op amp and choosing a particular value of gain, we'll be able to not only allow a pass band, have a pass band going through in an electronic circuit, also amplify it. So basically, what we want to do is discuss the theory behind such a circuit. Now, this is your sheet. Don't worry about the titles, they're all mine. So this is where we start. So the aim is to design and construct an active low pass filter using an op amp, study its frequency response and gain, hence determine the cutoff frequency and match it with the designed value. This is the aim of the experiment. Now, what is a low pass filter? I have said here. What do we do here? We give frequencies of different value to an op amp based low pass filter. In each case, a particular frequency is set. We measure the output voltage for that frequency. We plot a graph of gain versus frequency. And from the maximum gain, we divide it by √2 to determine where the power becomes half the maximum. In other words, the voltage output reduces by 1 by √2, or that is also known as the 3 dB point. The output reduces by 3 dB. Now, in a passive filter, as you know, amplitude is reduced. Therefore, we are using a op amp with a desired gain. These are the formulae. The cutoff frequency Fc is given by 1 over 2 pi RC. If you choose the cutoff frequency Fc and choose the value of C, you may use this formula to evaluate the resistance that you need to use in the circuit. The voltage gain experimental is given by V0 by Vi, where V0 is the output voltage. And since you are using an op amp in the non-inverting configuration, the gain of the op amp will be 1 plus Rf by Ri. So these are the theoretical aspects, formulae, etc. Now, what is the procedure? Before I go to procedure, let me show you the circuit diagram. This is your circuit diagram. Some design aspects also I have shown. If you choose a cutoff frequency of 750 Hz and C as 1 MHz, excuse me, it turns out that R is equal to 212 ohms. You can use 220 ohms. There should not be a problem. Okay. This is the pin diagram of the IC741. This is a bus. I should tell you this here. You have to give the pin diagram of all the ICs that you are going to use whenever you are doing the experiment, whether we have shown it in the manual or not. Please remember, we do usually give you the pin diagram everywhere before we start the experiment, but even if we haven't, you have to give. Please remember that. This is your pin diagram. Pin number 1, offset null. Pin number 2, inverting. Pin number 3, non-inverting input. Pin number 4, minus V or minus VCC or minus V source, whatever you want to call it. 5 is the offset null, which we are not going to use. 6 will be the output. 7 will be the plus VCC. 8 again will not have any connection. This is how we use the IC741. Now, this is our circuit. RF, you can take it as 22 kilo ohms. RI, you can usually get 10 kilo ohms. You don't get 20, you get 22. You can use it. This is how you give the various voltages. As you can see, the non-inverting terminal is where the output, the input is given. The inverting terminal is grounded. So, what is it that I do? I put an AC signal of, let us say, 1 volt amplitude of frequencies varying from 20 Hz to maybe 20 kilohertz. or even 200 kilohertz if you have the facility. So what we do, we apply 20 hertz, set the input voltage to 1 volt, we measure the output voltage between pin number 6 and the ground. We record the output voltage and the frequency here. So then what we do? Increase the frequency in steps of decades. That is from 20 to 100 in steps of 20, from 100 to 1000 in steps of 100, and so on. So you can go up to 100 kilohertz or 200 kilohertz. You can simply record the data here in the table. F, V naught, gain. Then what you do is you plot a graph of gain versus frequency. If you have a semi-log graph paper, you can even plot log F, no problem. This is the shape of the curve. Because it's a low pass filter, it allows frequencies below a preset maximum. So for low frequencies, you get a constant output. Once you go on getting closer to the cutoff frequency, the gain will reduce. This is the region in which the gain reduces by what you call as 3 dB. This is the 3 dB point. From the 3 dB point, you determine the frequency of cutoff. Compare it with the theoretical frequency that you designed this low pass filter for. So experimentally, this is the point which corresponds to the cutoff frequency. Beyond the cutoff frequency, you should see a steep fall. This is a 20 dB rate fall. Therefore, this is the first order filter. Anyway, you don't have to worry about that. So these are the essential things. So what is the procedure? Procedure, half of it I have already told you here. You connect the circuit as I have shown in the figure there. Choose a suitable value of FC. Choose a capacitor, say 1 μF. Calculate the corresponding R. Use it in the circuit to build up the circuit. Set the input voltage of the oscillator that you are connected to 1 volt. Choose frequency 20 Hertz. Then measure the output voltage. Then increase the frequency in steps of 20 Hertz and then on in decades of 10. So ultimately for each frequency you measure the output voltage, calculate the gain, plot a graph of gain versus frequency. From the frequency, choose the or estimate the point corresponding to AV max by √2. To draw a horizontal line, it cuts the curve at some point, drop the ordinate, that gives you the cutoff frequency. Compare the cutoff frequency with the theoretical frequency, you should be fine. If they agree well, you have done a good job. If you are not, if they don't agree, where is the fault? Most likely you would have chosen components wrongly that you can check and probably rectify. So essentials, these are the essentials. This is the formula, or rather these are the set of formulae for FC, for AV and for theoretical gain AV. Then this is the circuit diagram. The pin diagram first, the table, the circuit diagram. Please look at it again. This is the expected code. Even in the examination, when you are given this experiment, the first thing you do is give the pin diagram. Aim you don't have to write. Apparatus you don't have to write. Principle you write. Then below it, give the pin diagram, give the circuit diagram, give the empty tabular column as to how you enter the results. You also give the expected curve, show it to your teachers, get them verified, then only you start the experiment. Now for now, this should do as far as theory is concerned. In the next meeting, we will look at the demonstration of this experiment. For now, I think we should stop. Thank you very much.